So here we are, Foundations of Game Production. Let's see, 2:30 on a Friday. Yep, second class for the first week. And last week, I put the video up of what I talked about last week, and majority of it was understanding how to understand the class, but mostly about how to download and install Unity Hub and then the Unity Editor. So you should definitely have Unity Hub going. You should have definitely been able to install the editor. Some of you will probably have some Visual Studio issues, which we'll work on this class. But at least for right now, is anyone not able to install this version of Unity Editor? Right here, everyone's good. Cool. So what you should have done in Unity Hub is gone to Projects and New Project. And the two templates we're going to look at are 2D and 3D. And so we were going to create a 2D one, show where you want to place it, select your organization, and your project name. You can just call it like platformer, micro game or something like that. It's going to be a 2D platformer. And click create. And once you create that, you'll get a little pop-up that Unity Editor is opening. It's going to be creating a new project. It'll take a little bit of time. And then I introduced you to the asset store and the package manager. And from the asset store, that's a link here. And here are the 3 micro games we're going to look at this semester. But to start with, at least, let's get the platformer game open. Start with 2D, since usually 2D is simpler to approach than 3D. And you can click open in Unity, and there'll be a pop-up saying you want to open the editor. Eventually what happens is you get into the package manager, and just go here, click open. It'll just open in the package manager for me. There's platform micro game. And if you haven't already, it'll click like download, update, whatever. And I showed you the pop-up, and it's going to show you all the files in your project that want to come in. And some of them are new, and some of them want to be overwritten. And there's a lot of project settings that are overwritten. But anyway, at the end of the day, you import it into your project, and it should look something like this. And I kind of walked away last class with letting you do that, because that's going to take a lot of time. Was everyone able to get the platformer micro game installed, or is there any issues there?
I actually was having a bit of an issue, mostly because I tried installing it and I didn't realize I was not logged into my Unity account, okay. Or that I don't think I actually had a Unity account, and I didn't even realize it.
Okay, so you created your Unity ID with either your
yeah, and
email.
Yep. So right now it's just the project's just opening up, and I'm gonna import the package.
Okay. Yeah, you need your ID. We're gonna install the personal edition of Unity for free. And in Unity Hub, your ID should be showing. And in the editor, your ID is showing. And in the asset store, you're logged in. It's all the same ID. And then you should be able to import in the platformer micro game. And then if this scene doesn't open up by default, just go down into assets, scenes, and sample scene, and double click, and you can see sample scene is open. That's the top tier of our hierarchy. And we can also see way at the top up here, it says sample scene. All right, any other issues? Everyone else good to go? So I'll make a note, because I saw down here, I see this warning sign, and there's this warning, yada, yada, yada. So let me talk about these 2 panels or tabs. So we have the project view. This is like your file system. You can right click anywhere and say show in Explorer, and your file explorer will pop up, the Windows or the Macintosh version. And as you can see here, all the folders mirror what's over here. So, oops, I want to try console. So here we have our project window, and we have this assets folder which is opened up, and we can see like everything's kind of one-to-one that's on our file system. So this is like your file system. And notice that we have a bunch of meta files. So for each folder and each file, we have a corresponding meta file. So since we just have a bunch of folders on the assets with, looks like we have like 3 files, we're going to have all these meta files for the folders, and then we'll have like 3 files, and they're going to have meta files as well. If someone had a question. I'm getting a lot of feedback. It's either someone has a question or can you just mute yourself? Thanks. Let me just check the chat panel real quick. Okay, no questions right now. So, meta. This all relates to the folders. If we see here, here's one real file, and then there's a meta file that goes along with it. Here's a real file, and here's a meta file that goes along with it, and there's one too. This is just like top level stuff like notices and readmes. But for every file in every folder, there's going to be a meta file. And even if I like say jump into audio, it looks like there's 3, 6, 9 audio files in this folder. And look, there they are, and they have this corresponding metas. So one point to make is don't delete stuff in your file explorer, because these meta files are associated with each file and folder, and they're needed. So when you go into your file explorer and you just delete files without, you're actually messing up the Unity project, because it's using these meta files to manage everything. And so delete. If you need to delete files or folders, do it from your project view right there. And if you have to import stuff, you could just say, if you just like went to downloads and you have some stuff, you would just drag it and drop it over into your project view, and it would copy over the file, and then it'll create the meta file for you. So do most of your file managing within this project view. And then notice your assets folder is nicely organized. They try to have a folder for each type of file that you're going to have that relates to your game. So we have audio files and script files and prefabs and animation files. And in this one, we have tiles, like this tiling system that builds the level. And these are all files that are used to build your gaming project. And usually your gaming project is broken up into scenes. This gaming project is small enough where it's just one scene. But everything comes up and into the hierarchy. And the hierarchy is like your memory. It's like copies of your files are made and connected up and assembled together in memory to make your game. And so it's really at the hierarchy view is like all the little parts that make up your game scene. And so we have the scene at the top. There's the icon for it. We can minimize it, open it back up. Everything underneath is what's called a game object, and these are all parts of your game scene. Each game object, when you click on it, fills up the inspector. Here's like the meta level info of the game object name. Is it turned on? Tags and layers, which we'll get into later. And then they have components, and each one is like a really important little feature, modular part of the game object. This is where a lot of your script files will get connected in. So now we have this idea of a scene being broken down into game objects. Each game object can be broken down. Its behaviors or distinct parts can be broken down into components. So we have game objects and components, or entities and component systems. And they're usually coming from assets. And assets are the saved out file versions, and the game objects are in your memory. And the other thing I wanted to talk about was if you ever see down in the status bar, if things are popping up down here, this is coming from your console. And so your console will give you, there are three different types of messages. So you have kind of notices, warnings, and errors. And when you load stuff up and load up assets and you bring files into your um, gaming project, there might be some warnings or something that might pop up when you click play and run your game. Like when you have debugging statements, or if something goes wrong, the console will get messages sent to it. And in this case, we have three warnings. So the only thing that's going to break your game really are errors. And you can't click play if there's any errors. And errors can be like whatever code you've written might have syntax issues. There might be some bugs, um, or just something's weird. Some file is corrupted, or you added a component, but like it wasn't put on correctly, or whatever. There's errors that you have to fix before you can click play. In this case, we have three warnings. And when you're using like template or like assets or other people's stuff and you bring it in, usually you'll get like a bunch of warnings, and it's not always the end of the world. Some of the stuff is saying, hey, you're using obsolete stuff. You might want to like change your code or upgrade it. Or like you have variables that you declared or assigned, but you never ended up using them or whatever. But in this case, it's saying, hey, something about this tutorial manager. So it says like in this folder, assets, tutorials, tutorial callbacks.cs, on this line, this character in the line, we have an issue. So before I double click on any of these and move into Visual Studio, this looking at this folder structure reminded me that I didn't finish talking about file system here. So if I go in one of these folders and say I right click to get my menu and I say show and explorer, so everything in this you can see everything in this assets folder and all the subfolders right here in the project view, and we can see everything here. There's everything we have to work with. But if we pop up a level, now we're at the root of our gaming project. So I put stuff on my D drive and everything for this situation, everything under Unity projects, and here's one project. And if I pop up, here's like all these different Unity projects, and most of them are what are listed up here that I've opened actively. But if I just jump back into the root of my gaming project that I created with Unity Hub, we'll see that we have a bunch of folders, and then we have some files at the top here. So this is our Visual Studio solution file, and this is what like connects up all of our C# files over to Visual Studio, which we'll jump into in a minute. And usually we have a bunch of like config stuff and readme stuff at the top, and then we have the library. Then we have the assets is where we were just at. So the assets folder here. And this is everything we have to build with our project. And then we have some other stuff over here. So we have the library, which can be very heavy. And this thing is like managing a lot of cached out files. And it's managing if we like switch between different build platforms. And it has to go through all these asset files and change their settings based on whatever platform we're at. So, for example, any file in here you can click on, and the inspector will give you details on it. So just like you can click on a game object and get details on the game object as part of your game scene, the details are going to be about all the components that are connected to it. You can click on files or assets, and if you click on one, it'll show you its location. So here I am in assets, environment, sprites, and this is cloud.png. PNG is an image file. And here's like the import settings for this file that were brought into this asset folder. So it's like, what type of texture is it? We happen to be dealing with a 2D project, so it's set to 2D. 3D stuff will be set to usually default or normal maps. But then we have this set as a sprite. So now there's all these different settings, like, is it a single mode, multiple mode, which we'll get into later, and all this type of stuff, and then like all these, what type of color space is it in, and is alpha transparency. In this case, usually when we deal with sprites, we have to deal with an image file that has alpha, so RGBA, so red, green, blue, and A for alpha, and A means um, how transparent or opaque is it. So an alpha of 0 would mean these, again, a texture is just a 2D array of little pixels. And so some of them have color information and some of them don't. And if they're meant to be invisible, they need an alpha of 0, and they won't get rendered to the gamer's monitor, anyone's monitor. So anyway, this down here is the preview, and PNGs are one of these image files that allow for alpha. Like JPEG is just RGB; it doesn't have an alpha channel in it. But PNG is a common use for images that have alpha as part of it. And in 2D games, alpha is a big component because you just have these like little sprites, and they're just really rectangles. So which one are we not? Which pixels are we not supposed to render? And alpha will tell you that. But these are all the settings that came along for this file, and we can view them in the inspector. So the inspector is useful to view details in the project view, and it's also useful to view details in the hierarchy view. Now, this file has all these import settings based on the build type that we're in. So our assets folder gets populated with all of these assets that are prepped for the build. So if we go up to File, Build Settings, right now we're building for desktop standalone, so Windows, Mac, and Linux. But we could also install other optional, platform installs for Unity, and we could build for web, for Android, for iOS, for PlayStation, and so on. And every time you switch platform, it takes a long time because it has to go into the library, and it's got to all the raw files are in here, and they have to get the whole asset folder has to get updated and prep all these files for whatever platform it can run on, standalone or web or what have you. So that's what the library is, and in relation to assets. Logs are kind of where when you're building and you get a lot of automated tasks running, and they kick out log tasks and stuff, and they can go here. Packages deal with the package manager, so you have some manifest files and stuff. Project settings, so there's a lot of them, and project settings are up under Edit, Project Settings, and a lot of this was overwritten when we brought in the platformer game, and it already got set up for us, and there's a lot of default stuff. But this deals with input manager, how do we deal with different inputs like keyboards and mice and joysticks and VR headsets and hand tracking or whatever else. Graphics is a big one. So there's different type of rendering pipelines and stuff. Again, a lot of this stuff gets set up for you because you don't need to dive and learn all this stuff all at once. And the package manager. So physics is a big one. So you have to tweak this stuff when you get good at it, but it's how much processing should we devote to physics? We'll probably be using physics 2D, but a lot of it has to do with iterations and how many frames should be used up for physics processing, where should we process physics? Again, a lot of this is set up for you. Gravity might be a good one to call out. Right, that's a standard 9.81 meters per second. Oh, everything's in meters in game engines. We don't do feet. We do the metric system. So you have to get used to meters. And I guess a quick rule of thumb is like 3 feet is 1 meter. The player. So later on, like if you build this, if you actually build games, like you might actually have to know how to manage your company and product name, especially for mobile. This becomes really important when you have to like register for iOS or Android. Um, Resolution could be important. This is just default settings. So computer screens are in HD, more wider than they are higher. So we have more pixels to use with width than height. It's usually like a 1.3 to 1 ratio. Cell phones are the same. It's just usually people hold them in portrait mode as opposed to landscape. But again, all the default should be good to start with. Do you want to go full screen or offer a windowed version? And then you can do different settings for your builds for different build platforms. Quality levels are like a quick way. Like you could do a bunch of different tweaks here and say like, oh, for this build, I'm going to do medium, low, or high, and it'll like adjust all these settings. Usually has to deal with render quality. The only thing I kind of wanted to show with physics layers, time actually. So you can adjust time. These are like fixed time steps or fixed scale. So if you ever seen when you go into a pause menu that overlays a game screen and everything pauses in the game world, you can actually set the time scale in your game world to 0. So it's like we're stopping the simulation. Everything's not moving. We're not processing user input, and like let the user is just currently focusing on the pause menu. And then when we leave the pause menu, might go from a time scale of 0 back to 1. If you ever like reverse time or do playback modes or slow speed, bullet speed, that's messing with the time scale. I'm not really worried about version control. I probably talked about some of that later. But that's about it. Okay, layer collision matrix. The only other thing that might be of interest down the road is so physics simulations can be really expensive. So you can like turn on like different. It's like right now all the layers are interacting with all the other layers. So everything is like interacting with everything. And you can like turn stuff on and off. You can add more layers. When we talk about layers, we're talking up here like how to add game objects to certain tags and certain layers. So layers are really important. You put certain game objects on certain layers when you don't want all like physics processing on certain things. Maybe just a few game objects you really want physics processing with. All right, so project settings, and I think you can. That's just at a gist. Just like whenever you look at your game project and all of its files, just like what is happening and what is all this, and really when you're building your game, you just need to know like what's happening in your assets folder here. Cool. So to the project view, now we can go back to the console. Sometimes you'll get little warning messages like this, and that was because I was opening and closing different windows, and like you could just like just click this clear button, clear stuff out. And again, the only thing you really need to worry about is errors, but you will get a lot of these warnings. And if there's warnings or errors or even messages in a dealing with your code, like here, this is dealing with an asset, a C# script, you can actually just double click on it, or and it's a quick hand way of just like double clicking on that C# script, to open up Visual Studio. So you know that you installed Unity Editor and Visual Studio that came along for a ride. Everything works great as if you could do that. You can like double click on something, like a warning, and it opens up the right file and it jumps to the right line. Here we're at line 56. It notices saying we have an issue on line 56, character 13. So it's actually placing the cursor. It's just saying that if you hover over it, it's got this green line. It's just saying you're using this depreciated tutorial manager. So Unity tutorials.core.editor.tutorial manager. And all this tutorial manager stuff is because it's a bunch of editor scripting that allows for this tutorials window to appear, and that you can look at tutorials that are available for you that actually like change the editor and do some stuff. Like here's one like editor basics or changing colors of game object. And if you click on it, it'll change the editor and go through like an interactive tutorial with you. So it's like a lot of scripts just dealing with that, which doesn't actually have to deal with the actual game. And so again, even though it's using a depreciated file, I'm not that worried about it. But on top of it, it's not even dealing with the gameplay programming, so we can just ignore that stuff. So this right here, assets tutorial callback, we can go in the project view, and it's dealing with, now when I'm in the project view and I see these icons, these are nice, they're big thumbnails, and you can make them bigger or smaller. And sometimes this is helpful to view stuff, and sometimes I like to just pull to the left and just have a regular list view. And here's tutorial callbacks, and you can look at the little icons and see like, oh, this is a C# script. These are what are called assets. We'll cover these later. But you can click on one and kind of read the file name and then look at the icon and then see what kind of information is filled out in the inspector to piece together like what the asset is. Anyway, it was this C# script. We have a little bit of snippet of what the code is and double click on it and we can jump to it. Now that we've opened Visual Studio, I'm just going to talk a little about here because I just want to make sure everyone is able to open this. And when you double click on a C# script, it opens at the Visual Studio solution, and the code should look something like this. These nice different colors, greens and yellows and oranges and stuff. I just want to see, I might have like a different color scheme going on than you, but I just want to make sure that you have something similar to what's going on for me. So I'm just going to take a moment and see if everyone is able to get to Visual Studio. If not, we have to mess with like your extensions to get the Unity thing going. Okay. Well, if anyone has any issues, you just have to raise your concern so that we can help you along. All right, so I'm not going to go into coding yet. I just want to make sure people can open up Visual Studio and the code files working fine. Okay, that's fine. All right, so I'm going to open up my hierarchy. I got my game objects. I got my sample scene open. I'm going to click play, but let me check my audio mixer first because I remember last time the audio really blew me out. Okay. So normally you could be able to go into the player game object and you've got this audio source. Wait, audio. Yeah, it's an audio source, but where's the audio player? Okay, audio listener. All right, let me go back and turn my mixer back to normal. Let me turn off audio listener, and let me just make sure music's not playing. Okay, cool. So, so designs of game scenes, the way that they're pieced together, either the game objects and the script files, um, it opens in a new window. The Visual Studio does. I mean, it should open up Visual Studio for the first time. Open up your project, and then open up a tab, and it should look like this. It doesn't look like this.
I think it might have been opening up a different version of Visual Studio, which is why I got confused.
Sometimes I just close all Visual Studios and then go back to Unity and double click, and then like it should start up fresh and be clean. So I was hunting around in Player for my audio. So there's audio sources, and ultimately there needs to be one audio listener, and that audio listener is what like pipes to your speakers or your headphones. And I was looking on the Player, but it's actually on the main camera. But let's take a look at some of these game objects and see, like, maybe get inside the head of the developer and see maybe what they're breaking apart here. So we have game controller. So these are all names of the game objects, and they should give you some idea of what's happening here. So on game controller, we see that we have everything needs to have a transform component, because there needs to be like a position in the world. So every game object will have a transform, and the only gotcha with that is that UI stuff will have like a rectangle transform, which we'll get into the reasons for that later. But a transform has position, rotation, scaling information, and that's how you know how to place stuff in the world. So it's a required component. Now we have our game controller, and you can see that the script here, it's a script, and this little icon means script. And we have token controller. So this is like, okay, it's something. This is like controlling the game at a high level in some way. Token controller. So this is controlling the tokens. I'm gonna guess that the tokens are these diamonds we're collecting. In fact, here's tokens. So I'm gonna zoom out and just turn it on and off. And yeah, these are like these sparkly diamonds we're collecting. A metagame controller. Okay. So something, maybe game controller is like all the details in a level, and maybe the meta game controller is like the high level stuff, like the start, like are we in the start or like pause menu or game 1 or 2? I don't know. We'll dive into there. I'm doing guesses. That's why good naming conventions are really important. We do have our audio. Oh no, it's an audio source. Okay, so an audio source is playing something. You have multiple sources. It looks like it's just playing like the background music to the game level. Here's like a bunch of settings for audio. We'll get into that later. It happens to be like a really big one, so I'm just going to minimize it because I want to see if there's anything underneath it. So you can minimize components if they get like really noisy. You can minimize a lot of stuff. Like you can open and close hierarchies and folders and what have you. You can kind of think of the object hierarchy, the game object hierarchy, is almost like a folder structure. So all this stuff is hierarchies or tree structures, and that just means that you can like have the potential to go down into other children locations. There's stuff underneath stuff, and you don't know the exact like structure of it. There can always be folders within folders within folders in different ways based on how you're creating them. But at the end of the day, there's like a file sitting somewhere at the end of that folder structure you're trying to get to. Now you can think of the hierarchy in your game scene as a similar way. There's just game objects upon game objects upon game objects, much like there's folders. And we do this with game objects because we're organizing stuff. For example, we wanted to put all the enemies underneath one game object, kind of like it's a folder. But we also, for our game logic, found it was easier to put our patrol paths for our enemies under there as well. So our enemy's game object, or which is empty, by the way, it just has a transform. It's more of an organizational game object. It's functioning very similar to a folder or a group. Has within it all of the enemy game objects, which are a real enemy that has graphics and animations and behaviors. And it also has their patrol paths, which are just a script that says like the start and end position that where they're supposed to move back and forth. So anyway, it's like all the logic for enemies is sitting underneath here, which kind of like a folder. Now we just went through game controller object. I'm not looking at anything in detail. I'm just kind of giving you like a high level of where the stuff's at, what I'm thinking the developer was thinking. We have this UI canvas, and notice it's like muted. It's turned off. We don't have the UI active right now. This is probably like a pause menu. But notice this game object is colored a little different. It's blue. The icon's blue. The text is blue. So this is a prefab. And in fact, if I right click on it and I can say select asset, it'll pop me down into the projects. Okay, it's in the prefabs folder, and there it is. There's the UI canvas. So if I take this prefab, which is a file, and I bring it into my hierarchy, it's like copying an instance of it. Make one active game object. Make one instance of this prefab live in my memory. And we can see that I can open it up, and it's got a lot going on in it. It's a whole hierarchy on its own, right? It's a whole island, a whole world on its own. It's doing a lot of things. So it's complicated. And it's probably reusable. So whenever we have like complicated reusable game objects, we drag them down into our project to save it out so that we could reuse them often. And that is what a prefab is. And that is the relationship of a game object to a prefab. And so we have this UI canvas, and all these components are normal. They come along with the UI. This is normal, and then this one has been added just because I know what the components look like. So here's a UI controller. Somehow this thing is managing the UI. We'll take a look at that. But if I click play, let me take a look at what this thing looks like. Music blast. Oh, okay, let me turn that off. Sorry, I got an earful. So I'm gonna click play, and one thing to know is don't destroy on load. It appears, and it looks like a different Unity scene. And if I open it, there's some stuff in it. So this is some stuff we can talk about later. This don't destroy on load. Just make aware of it. So if I hit the P key or the escape key, okay, it's the escape key. Notice my UI canvas is now active. So escape means to go into some type of options menu or something. And I'm actually hitting the button. So notice my game world is paused. Probably the only thing you can notice is that he's not like having that resting animation going. So you trust me, my user input is not active. And this is just giving you some, okay, look, here's some directions. And it looks like there's some buttons down here. So you can go to main and settings and controls. And there's nothing really implemented here. It's just saying you could use this area. It's like empty. It's like you can fill it out if you want a main settings and controls in the credits section. So this might be a good activity for us to look at how to fill this stuff out and make it interactive. But anyway, it's a menu with 4 buttons and 4 scenes that switch between it. In fact, if I open this up, watch as I switch clicking between the buttons, look how different game objects are turning on and turning off. And this is like how a lot of gaming systems are working. So we're just turning on and off different game objects to turn on and off different scenes and different buttons. All right, so I press the escape key, and now I'm back into the game, and the UI canvas is turned off again. So I found the functionality with this. So we have a main camera. There's always got to be a main camera, the main camera. So notice I'm in scene view. This is the developer view. This is like my God view. I can move anywhere, do anything. And then when I click on game view and I click play for test playing in editor, this is the game view. This is what the player sees. So how is the player seeing stuff? The main camera. When I click on it, the main camera view is the same as the game view. And if I zoom in and let me pop out of 2D. So in the 2D, this is this 2D, 3D button. 2D mode like pops your view down to this orthographic, flattened, like no perspective view. Or you can pop back out and you can move around in 3D. I just want to see where this camera is. So it's sitting off. It's where this little gizmo is looking this way. It's off of the game world. So the game world is this like really narrow space right here in our 3D world. And the camera's moved off from it. So I'm going to go back into 2D. All right. So I saw where the camera was. Now, some things to notice with the camera is that it's a special component, this camera component. And then here's the listener piping all the audio sources in our scene out to our speaker. And you can notice that there's this icon here called Cinema Machine Brain. Cinema Machine is something that Unity bought up a few years ago. It's just to helps you make more advanced camera movements. Usually it's just really helpful to pin the camera onto the player and make it move with the player. So all Unity is in 3D. So if I zoom out, we're in a 3D world. It's just when you create a 2D game, there's some settings, some project settings. One of them is default your scene view to 2D. And one of them is when you import in textures, instead of setting those textures up to a default 3D, usually in the 3D world, a texture gets connected to a material, and that material gets applied onto a 3D model, which we'll talk about later. But in a 2D world, the texture just is almost like its own, is applied onto a little rectangle and just put out into the world like a little billboard. And so the import settings are different. Anyway, the long story of it is both 2D and 3D projects are in 3D in Unity. It's just 2D projects have a little bit different default settings for them. So main camera. So some things to note. This is an orthographic camera, not a perspective camera, because we're in the 2D world. If you're not familiar with these terms, you view the world out with a perspective distortion because you're in the 3D world. So lines of something will converge on each other. So a common situation is, I'm surprised they're not showing railroad tracks because that's kind of how they always show off perspective. Yeah, here we go. So notice that these railroad tracks, in reality, not reality, in the way that your vision system works, all lines, parallel lines, converge onto one point. This is how we interpret our 3D reality with this perspective, and then this is how perspective drawings are done too, where parallel lines will converge on each other. This is how we're used to viewing our world. But orthographic, and that's why perspective projection from a virtual camera, kind of all these lines are slowly converging into one point. Where orthographic projection, there is no distortion. Like a cube is a cube out. It doesn't have, so it looks weird to us because it's not following the way that we're used to viewing the world. But orthographic projection is very useful for 2D games and for user interfaces, because user interfaces are flat as well. And so when we view 3D objects, it makes sense to do a perspective distortion where things farther away are smaller and things near are bigger. And then over here is orthographic, where something far away is scaled just as big as something close, because we don't have this distortion, this perspective distortion. So anyway, just be aware that there's these two camera views. And like even when you build a 3D game, you're going to have a perspective camera for all your 3D content, and then you're going to have an orthographic camera for your UI, for your flat content. And so our main camera, since it's a 2D game, our main camera is orthographic. And then there's a bunch of stuff like how big is it? The size, like how big is it? It's just I can't even mess with these because the cinema brain is on. It's just how big of it, like the box, how big is that box of it rendering that you saw in the drawings. And then clipping planes are very important. Usually they'll show the full strum of the camera. Let me just create another camera real quick. Camera. Yeah, they're like not showing the little icons. Just give me 1 second. Yeah, I can just clip plane, but it's not showing. Usually there's like a little icon of a camera, and it'll show you the full strum, the viewing range of it. Maybe because it's in a 2D setup, maybe we'll see it over in 3D. And I can talk about cameras more in another project, but it doesn't seem to want to show. Okay. It's kind of weird. So here's our camera, and this is the orthographic camera. And as you can see, it's like a big cube. It's going off into the distance. And that's this near and far clip plane. Now you can't like render everything in your game world. It can be really expensive. You don't want to render off to infinity. I can't change these settings on this camera, but this one, yeah, this one I can. All right. So this is my perspective camera. Notice the difference here. Notice the perspective camera's got this like pyramid shape. It starts off at the viewing position, and then that is like the small little dome of the pyramid, and it gets like super big. All right, and then you can adjust. This is how big the field of view is. So like these are based on real world cameras. So you have like fish eyes and wide angle and blah blah blah. But we model these cameras normally off of like the human range, which is 60 degrees field of view here. And the only other thing I want to talk about is these clipping planes. So like as I shrink down the far clip plane, notice that my pyramid shape is getting a lot smaller. And this is like what's allowed to be rendered in the view of the camera. So notice as the far clip gets really small, it cuts out the actual game world. So you don't want that. You don't want that like really small viewing range. But And rendering to camera, you know, we look at what we're supposed to clip out because rendering can be very expensive. And actually, in physics too, it's like, okay, how far out do we want this physics, this raycast to happen? Because usually you don't want to go off to infinity because it's too expensive and it'll just eat up all your processing time. So I decided to take these clip planes and fields of view and what have you. All right, so I'm going to delete that because we're going to go back to our 2D camera. And I was just saying this far clip is like, wait, you don't need that. You can move it all the way up, but you can't even mess with it because the whole camera is being controlled by this cinema machine, which is great. That's fine. That's the game developer wanted to use it because it's a Unity tech and they want to show it off. But anyway, it makes like the camera's gonna follow the player and it makes it feel really good, like Super Mario Brothers or something. But it's doing all these like advanced camera moves that take a lot of code. It's already like done a lot of stuff for you. So that's what the cinema machine is. Um, these post processing volumes are like when you want effects. Again, like particles or smoke or God rays coming from the sun or all this stuff. They're processed and they're done in a volume of space, but it has to be a finite volume. You can't do it throughout the whole virtual 3D world. It's too expensive. So sometimes you have these post processing volumes, like volume bloom. Bloom is it's kind of it's like turn it on and off. I don't know how prevalent it is, but it's like the whites become much stronger. It's like the light, you get that like soft like blowout of light from light sources. That's what bloom is. So anyway, these are all like um, nice extra. They call them post processing effects on the camera to make the game look really good, like a vignette. Notice how the edges are darkening, like your eyes focus at the center at the player. So that's what's called a vignette. Film grain is when it like you want it to look like old film, just a little graininess around. You can play with the intensities and stuff. That's what all this camera stuff is. That's a beauty. One of the more additions of using Cinema Brain, you get all these nice visual effects. All right, so the event system comes along with the UI. The event system helps with user input. Um, Interacting with the UI is like can be require a lot of crazy code. There's a lot of things that you just don't think of when users interact with sliders and buttons and stuff. And so a lot of that's been abstracted away from you with this nice event system. So anyway, this comes along with the ride with the UI system. Here we have some type of virtual camera. So machine virtual camera. And again, it's like confining. It's dealing something with moving with the sticking with the player transform. Follow the player transform. Look at the player with the here's the lens size. So if you want to notice as I increase this. Okay, so this is controlling the camera over here. Notice our size, our ortho size over here has changed. So anyway, notice when you increase that big rectangle that the camera is rendering can increase. And so this is a smart camera. Notice how I keep zooming out. It's not like centering up on the character because the game world on the left, there is no game world. So when you zoom out that far, it's a smart camera. So it's choosing to like expand out into the playable game level. So this is all part of Cinema Machine 2. But I'll put it back to default settings. Oh, here's a near and far clip plane. Cool. So that was bothering me. So I guess I got to click on this button to see like, oh, toggle visibility of gizmos. Okay, I should probably go through what all these little buttons mean too. But I want to decrease this far clip plane because that's ridiculous. That even like 100, look, 100 goes well past this game level. This game level is like 1 meter, like 1 unit in size or whatever. So anyway, I don't need to render that far out. It just bothers me. I'm probably doing nothing to save processing. I just don't. It's just wasteful. Cool. So you can mess around with your camera with this virtual camera component. This confine here. This is this sure it's this yellow thing. So confine the scene edges. Oh, it's this confiner. Yeah, it is this thing. It's just another game object that's just the confiner. And all it is a polygonal collider 2D. It's just they drew out this shape. It's this one big polygonal physics collider. And this just is the whole outline of the game level. And that's all this one game object does, and it feeds into the camera. That's how the camera knew, hey, I'm hitting, when I kept increasing the ortho size, and it hit this yellow edge here, and it said, oh, I'm at the edge of the game level, so I'm going to go reposition myself, and I'm going to grow out toward the game level, because I'm just going to be showing dead space to the user, which is not a good user experience. Cool. So that covers this stuff. That's all still part of the cinema machine, whatever. But here's the big one, the player. Okay, so notice that the player is a prefab because usually there's multiple scenes, level 1, 2, 3, 4, and you just want to drag in your player prefab and not build it from scratch. So notice that it's tagged as player. We'll get into tags later, but game objects have names, and you can find game objects by names. They also have tags, and sometimes it's easier or cheaper to find something with a tag, and also with a layer. So we have this player controller script, a lot of stuff going on here. We're probably going to take a lot of time in here. But it looks like it's controlling its audio, its gravity, its speed, what state it's in, health, what have you. Is it control enabled? So I bet you this turns on and off when we go into our pause menu, because I can't control the player. So I bet you this is the Boolean that's controlling that. Oh yeah, control enabled, off. Where did I focus on that? Let me try one more time. Okay, I'm controlling him. That's turned on. Escape. All right. We'll dig into that later. So that usually when you see that, you say this is a publicly exposed bool. You can see whether your control is enabled or not in that. So there's a sprite render. This is controlling the graphics and how the character is being rendered to the screen, and the animator. We're going to get to animators, different animation states. In 2D, this is like controlling different sprite sheets, different sprite graphics. And in 3D, it's usually controlling like animation files that were created in 3D packages. And usually the characters are rigged with these bone systems, and it's controlling the mesh. We'll get into that later. And a rigid body. So for it to have this character be a part of the physics system, they need to have a rigid body. Rigid body for 3D, rigid body 2D for 2D. He's playing some audio that's probably being controlled by the player controller. He's got some type of health script, and he's got some type of collider. So if I click on that, just because this is the shape of the body, that's just the graphics, and that's way too complicated of a shape to do physics with. So when we do physics, we use much simpler shapes. Like we really only need to know the bottom of the character, so that when his bottom is touching like the ground or touching an enemy, we only really need to know about the sides, like when he runs into an enemy or runs into a collectible. So some simple shapes like circles or squares, in the case of the player, square was more than enough to have like, okay, there's some sides, a top, and a bottom, and we can figure out what's happening to the player just with that. And there's a material that's connected to the sprite render. The spawn point is just a location right here, and it's just used. Notice it just has a transform. Notice we just use this to know where to spawn the player when he dies. The grid. Okay, this is the tile mapping system. Notice it says tile map renderer. So this is how they built the foreground, which looks to be, if you zoom out, it's just these 4 parts with the orange around them. Not sure why they decided to put that separate out from the level. Because these are probably hidden. You could probably jump through that. Let me just take a quick look. Yeah. Okay. This is how they're creating hidden passageways. I don't know. You're supposed to do something with him, but the reason that this stuff's foreground is because it has graphics, but it doesn't have a physics collider on them. Notice that on the level that we actually can interact with, the walls that we hit and the ground that we stand on has this tile mapper collider on it. It has a physics collider so that the player has physics collisions with this. Whereas the foreground are hidden. Look, you can walk through that stuff. All right. Background is not far background. Okay, so it's the buildings. It's the buildings and near ground and clouds. Interesting. It's about half the clouds, and the other half the clouds are in the far background with the big distant mountains. So they broke up near. Basically, it's near background, far background. So in the 2D game, you could do little parallax effects. Notice how this is the foreground, which is moving at a different speed to the near background, and even the near background is moving left and right at a different speed to the far background, which is this pyramid and this cloud. So it's just about different speeds. It's faking the concept, the feeling of distance. It's really like if this thing was a few hundred feet away, this is a few thousand feet away, you would get this type of feeling, this type of movement. So anyway, that's a parallax effect. It's just to make it feel more real, and that's why the stuff is broken up with the background. And notice background and far background, they don't need a physics collider because you're not colliding with them, but they have this parallax layer, which seems to be messing with the movement a bit. While I was clicking play, I just noticed when you have this, if you're clicking play, you'll notice the camera doesn't move till like you get. So notice how I can move within the center of the screen, basically, and the camera's not moving. And then notice as I get toward the edge of the screen, the camera starts to move. So that's like that advanced camera control, like a normal, just a camera that you just like kind of parent to the character wouldn't do stuff like that. Anyway, background. I don't think there's anything on this layer. There's just this grid thing and a parallax. So I think they abandoned it, and they were like went with this setup here, and it's just a leftover of an idea that didn't work out. So we have all our enemies, and if I click on one, it's these blobs, and they have a renderer. They're tagged as player. That's weird. They should be tagged as enemy, but whatever. We'll see how that's working out. Sprite renderer, animator. They got a rigid body, so the animator will make them the ability to change their graphic, make them look like they're moving. The rigid body means they can interact with the physics system, and then they have a collider. So normally, you'll see with the coin thing, it's just going to have a collider. But normally, if you have more advanced physics entities, like the players or the enemies, they need some type of rigid body to be more involved in the physics system than just a collider. but normally the collider to start with, and then the rigid body gives you like more physics abilities. Now we have this animation controller and this enemy controller and the audio source that's playing, and this material is referencing some material in the sprite render. Yeah, I don't want to get into the details. I'm just giving you like big overviews. So patrol paths, if I click on one, it's just a location, a transform, and then it has this patrol path, start and end position. So it's basically like X is left and right, Y is up and down, Z might be used for like placing and building the level, but since we're in 2D, Z is forward backward. We're not like the characters aren't gonna think about it. So I think this is saying like, okay, here is the center of my patrol path, and the start position is gonna be 1.3 units to the left, which left is negative is to the left, so it's somewhere over here, and end position is somewhere over here. So if you ever wanted to like look at those numbers, you could duplicate it, and we could delete it afterward. Control D is duplicate. But you could say, okay, negative 1.3 would be 15. So you can see where it was placed, like right at the edge. We have to go into 2D view to understand the feel of it more. It's like right here. And then it's also saying go 4 units. So it's at 16.3 and then plus 4. You could do little math in here too. So it's saying in the endpoints here. So he's going to patrol the whole length of this area. All right. And tokens. We have some type of sorting group at the top. That's interesting. I have to look at what that does. But these are these little tokens that we're going to pick up. So it's got position. Here's a sprite render, and it's dealing with a circle collider. So if I click here, we can see anywhere in this area will generate like a collision. So usually we have 2 colliders, and you usually have a script that says, okay, on collision, meaning check when this collider has touched another collider. And so notice we just have a collider here. We don't have a rigid body because it's just a really simple, it's like a floating grab. It's not anything sophisticated. All right, we have the script here and a material. And then zones. So it looks like these are all death zones. So what are they? This is a oh, okay. So I clicked on edit. I just clicked here and I'd be like, okay, this is a collider. It means when the player runs and falls, we need a way to tell if he fell down this pit. So if the player is at this state, there's like no way he's going to get out. Maybe if he's around here, maybe there's a chance that he can do something, but we know if he's down here, you're dead. We're just going to kill you. And so there's a collider and this death zone script. And it looks like we have one. Looks like we have one here that covers all of here. It covers all of here. Looks like this got a little lazy at a certain point. I mean, look, it's very close to here. It's kind of shoddy work. I wouldn't have a collider this close to where someone would run. Anyway, I mean, it's an easy trick. You just grab this and move it. Be like, nah, don't have your death zone over here. In fact, this one is covering this whole. Sometimes people do work real quick. You know, just this is a little close. I would just open that up a little bit. And this one, there's already an overlap over here. I wouldn't even have that. This one's really meant to cover here and cover here. And this is a little close. I might move it down a little bit. Anyway, you see the point. This is covering these areas and these areas. And we have another death zone somewhere over here. Okay, so you're allowed to slip through this hole here and come down. And if you are able to make it in here, then you're okay. Otherwise, you die. And this one's covering over here. I'm not really sure why, because if you're standing here and you jump and you keep, like, depending on what type of velocity, you know, you can get to. You might keep going, but all you got to do is then, if you're scared of the player jumping and not and like being able to pass this, then just do that, and you know that he can't actually ever get over here, and then you don't need this zone. Anyway, and then we have victory. Okay, and what's that? It's this little square that covers this yellow door. All right, and it's the victory zone script. So those are zones for death and victory when we know, okay, the player should be die or the player actually beat the level. And then we have alien. Okay, this little guy, the special place. He's got a renderer and a collider, but there's no scripts. I guess his left is like a to-do, like in the tutorial, like, okay, make a script on it that you can get, like, if you meet with him, he'll give you 100 coins and he'll teleport you to, like, the middle of the level or something. Cool. So that was my overview, run through. We're actually running. That was a longer class. Usually I don't really go that long, but sorry, usually there's a lot to talk about. I just wanted to give you a quick run through of like the parts of the game and how they're like connected with the hierarchy and the inspector and the project view and the console, and making sure you can open up Visual Studio and what all this stuff is doing. We'll get into details and we'll break down into like subjects of like rendering and animation stuff. But that was like a huge run through this game project. All right. So happy trails, happy have a good weekend, and appreciate you being flexible with me this week. And I will see you on Tuesday.
Was it a quick question? I can take that. Was I gonna ask a question?
Yep.
Yeah, I was gonna say. Was this video recorded, or are you gonna upload another video for what's it called, for this section, or for this week, I should say?
Oh, I'm gonna stop.